Okay, I've got a 1 kilogram mass and a Newton scale. So the Newton scale will show how much something weighs. So how much does a 1 kilogram mass weigh? Okay, if you said 9.8 or about 10 newtons, you're correct. Okay, now we're going to put this 10 Newton weight, we're going to put it right at the midpoint here. You see I've got a meter stick suspended from these two spring scales. And they are equal distance apart. I've got this one on the 10 centimeter mark, this one on the 90 centimeter mark. I'm going to put the 10 newtons right at the 50, right in the middle. Predict what will each scale read when I put the 10 newtons right in the middle. If you said 5 and 5, you're correct because it's equally distributed. We've got 10 newtons going down, we have to have 10 newtons going up, so 5 and 5 is 10. Now, what if I were to slide this mass towards the left scale here? What would happen to the left scale? What would happen to the right one? Okay, the left one now reads about 7. The right one reads about 3. So if you said this one will get bigger, this one will get smaller, perfect. And they still add up to 10. So now what if I put this mass, the 10 newtons, right underneath the scale on the left? Yep, we've got about 10 and about 0 there. So it still adds up to 10. Okay, I've replaced the meter stick with a string that goes between two of the spring scales. So when you put mass here, it will sag that string in the middle. I've got the same 10 newtons. I'm going to put the 10 newtons right at the midpoint of this string, right in between the two scales. I want you to predict what each scale is going to read when I put the 10 newtons right at the midpoint. So go ahead and make your prediction. Ten newtons right at the midpoint. We should see 5 and 5 again, right? Okay, let's try it out. 10 newtons right at the midpoint. What do we have here? We got about 6.5 and 6.5. That does not add up to 10. But the string is going at an angle. It's pulling the scale at an angle. It's not pulling it straight down. Here we have 10 newtons going straight down. So draw a free body diagram of this. Okay? We've got 10 newtons going straight down. We have to have 10 newtons going straight up. If it's right in between these two scales, we should have 5 up here and 5 up here. But it's also pulling horizontally. So it's pulling this scale to the left, it's pulling this scale to the right. So I calculated this out, and I made some vectors here. Okay? So here we've got this one, 5 newtons up, 4.2 newtons to the right. And on this one, I've got 5 newtons up and 4.2 newtons to the left. So the 5 and the 5 up will add together to give us 10 newtons. We've got 10 newtons going down, we need 10 newtons going up. The 4.2 to the right, the 4.2 to the left, they're going to cancel each other out. So that is equilibrium. The net force is 0 in every direction, x and y. That's equilibrium.